So a quick one here. Energy and temperature to start with. These are revision questions. Temperature is measured in degrees, while internal energy, which is thermal energy, is measured in. And of course, the answer is, did you say joules? Yeah, you will be right. Joules is the right answer. Number two, the amount of internal energy stored in an object depends on the following except, most likely the atmospheric pressure, atmospheric, the temperature is important, material and the mass. The next one, question, when two objects have different temperature in contact with each other, and contact energy will be transferred from, is always from the hotter object to the colder one, until the two of them are of the same temperature, of course. That's equilibrium conduction. This is the primary method of heat transfer in, of course, that will be in solid. In solid, that's correct. And the next one is, how does conduction transfer heat from a true or solid? It's mainly, particles are not freely moving, they are not moving at all. In solid, they are vibrating about them. So the right answer will be option C. The vibration from one particle will pass the heat energy to the next one, and that's how conduction takes place. And number 6, which material listed below is the best conductor of thermal energy? This is very common, and the right answer is metal. Convection question here. Convection takes place in fluid, not liquid. Fluids. Fluid is the combination of liquid and gas. Okay. Question 8. Convection currents are carried when a heat fluid becomes less dense. And what? So basically, if you look at this image here, the particles below here would rise up, while the one on top would, which is cold, would go below. So it's forming some kind of a circle. So that would be like less dense, fluid becomes less dense and rises, causing cooler, denser fluid to sink and replace them. That would be the right answer. Evaporation here. Evaporation causes the remaining liquid to cool because the fastest particles leave, decreasing average temperature. That would be the right answer. This one here, the particles with more energy would move to the surface of the liquid and they would evaporate. So the one below would have lower amount of energy, of course, and that would reduce the average energy. And the next one, infrared radiation can transfer energy mainly through empty space, which we call vacuum, remember? Okay, so when you see vacuum and empty space, I'm saying the same thing. A dark dull surface is a good, now by the way, a dark surface is a good absorber and emitter. So someone who can take, absorber, must also be the someone who can release. So the best answer is a emitter and absorber of radiation. Now a light shining surface, for example, is direct opposite of dark, so is a poor emitter because, of course, it's a poor absorber. That's it, the reason. Just like what we had for question 11, a good absorber is a good emitter. So a poor emitter would be a poor absorber. Oh, okay. That means A will not be the right answer in this case. Sorry for that. A will not be right. I didn't read the other part. So it's a poor emitter because it is a good reflector. Yeah, it's a good reflector. That would be the right answer. If I say a good absorber, then I'm saying it's black, so that would not be right. So the right answer is C. Thank you. Power and energy units here. So where power is the rate, is defined as the rate at which energy is transferred. Is 1 joule of energy is transferred each second. So remember that power, let me make this a little bit deeper. So remember that power is energy over time, right? So if power is energy over time, I think that's too much. Okay, power is energy over time, so energy will be power multiplied by time. Okay, so power in this case we don't have, but we have energy anyway, so we're going to stick with this. Energy is 1 over time is seconds, that is 1. So that would be like basically watts, because power is in measures in watts, so it's going to be 1 watts. So the right answer is C. 14. If 500 appliances, a watt appliances is used for 2 hours. Now the key thing I'd like you to take note is the unit. It's measured in kilowatt hour. So we just do watt times the time, then we convert to kilowatts. So it's just going to be like 500 to kilowatts. That will be 500 divided by 1000. So that will be 500 divided by 1000. That will be 0.5 kilowatts. Now I will now multiply the 0.5 kilowatts by 2 hours. So that's most likely is going to be 1 kilowatts hour. So the answer would be option B. Okay. Efficiency talks about useful. That's very important. But percentage of energy that is useful, that's what is called efficiency. And in Sankey diagram, the width of the arrow that splits off. Remember, Sankey diagram is like the flow diagram that describes energy flow into maybe a continent, a planet, the world, and whatever. Europe have their own and all that. So it talks about the amount of energy that is going in. Okay, amount of energy that is going in. The width, the larger the width, the larger the amount of energy. The device has a total input energy for 400 joules and a useful output of 300. So what is the efficiency? Efficiency is the useful I mentioned the other time over total, and this will give you 0.75. So you multiply by 100, you get 75%. So that will be option A. And payback time is the time taken for the cost of an energy saving instrument to be matched by the cost of the appliance. It replaces, yeah, that would be right. Let's look at that one. The money saved, the energy saved, the total power. So the right answer is option A. So the saving you make from one usage, you use it to get another one or to take care of another installation. That would be the right answer. Number 19. 1005 is the cost of the window. 300 pounds is saved per year. So we'll just do 1005, which is what we are trying to replace now, divided by how much do we save per year? 300. So that will be 5 years. So that means it's going to take 5 years saving this to be able to replace the window. So that's option A. And 20, which statement is correctly describe the difference between accuracy and precision? Accuracy is about getting similar result. Precision is about getting close to the true value. No, accuracy is about being close to the true value. Precision is about getting similar. That's the right answer. So getting repeatability. Repeatability is this, while correctness is this. So it's getting close to the true value, that is correctness, and repeatability is getting similar results. So that's for the first 1 to 20.